Hello, everyone, and welcome to another awesome Kubesimplify workshop. My name is Sayam Pathak, and I am a CNCF ambassador working as Director of Technical Evangelism at CIVO. And these workshops, these power packed Kubesimplify workshops, are completely hands on. Until now, we have covered Linux and Docker fundamentals, Kubernetes workshop, GitOps workshop, chaos engineering workshop, service mesh workshop. So I think we have covered a good amount of workshops, and yeah, container security workshop as well, container and Kubernetes security. So now, even moving further, so we have not only stopped with the basics with learning Kubernetes. We are now building on top of Kubernetes. We have learned Kubernetes security. We have learned chaos engineering. We have learned service mesh by doing. And today we'll be learning Kubernetes troubleshooting, which is like you will definitely be dealing with Kubernetes troubleshooting. If you are DevOps, you are an SRE, Kubernetes engineer, anywhere you are administrating Kubernetes, you will be dealing with this. Any certifications, CK, CKE, CKS, you will be dealing with Kubernetes troubleshooting. And there's no better person you are seeing on the screen besides me, um, uh, you know, who can do this better because. Um, David, aka Raw Code, by his signature name. So he has his own YouTube channel, and there he runs a series called Clustered, which have been on twice as well. Like an amazing initiative, amazing series where people come, break clusters, and other people fix clusters live. And I think it's amazing. There have been a lot of learnings that the whole community has taken from the Clustered series. There have been a lot of issues that people have found during these breaking and fixing the clusters. A lot of techniques that people have shared when they are troubleshooting and fixing the clusters, which are amazing. And David has been through all of them, so he knows the baddest of the bad fix, break, and how people do like different styles of fixing the clusters as well. So happy to have David here. He actually never says no to me. He's my good friend. We have been doing this cloud native streaming, cloud native videos since like more than 2 years now. I mean, there are people who start and then they pause, but we have been consistent, and that's why David is a like cloud community is lucky to have David as one of the content creators. So I think we all are very lucky to have David today and learn Kubernetes troubleshooting from him. So few things first, make sure to subscribe to David's YouTube channel. Second is to follow David on Twitter. Anybody who's watching live, please do that right away. And the third is please be respectful to each other in the chat. There are moderators who are moderating the chat, so we are here to learn. So let's kind of learn it. With that, David, thank you for being here, and tell us more about yourself to the community, and let's do some Kubernetes troubleshooting.
Yeah, I had to cough right there where you introduced me, but thank you very much, Sam. Yeah, I think you've covered all the important things. My name is David. I'm in Glasgow in Scotland. So I live in a country that is wet and cold, and we're all very miserable and unhappy and grumpy. And that's why we invented whiskey. Now, I spend a lot of my time working as a staff developer advocate for a company called Pulumi, helping people adopt infrastructure as code. But broader than that, I am an active member of the cloud native community, along with Siam and, of course, everybody watching this. We're all in turbulent times as cloud native evolves, and Kubernetes is, simplifying some things, but bringing a whole lot of complexity to other things. And, it's through sessions like this and the good work that Siam and other creators in this space are doing that give us all the opportunity to learn valuable lessons from everyone else. So just thank you to Siam for having me. I'm excited to guide you all through a few clustered sessions today. They're a mix of broken Kubernetes control planes, some Linux stuff, and some Kubernetes workload stuff. So you're going to see full spectrum, what it looks like to operate and work with Kubernetes. And like I said, I'm excited to take you through it. So thank you, Sam.
Yeah, so Raw Code Academy that you see in the chat is David's YouTube channel. So someone was asking that. So make sure to subscribe to that. Yeah, I think Anurag has given the link as well. So you can do that. And thank you, Engin. Engin is the biggest supporter of our cloud native ecosystem, to be honest. So, and we all love Engin. So, thank you for being here. And yeah, David. So, you asked me to post a link in the chat. Can you tell us a bit more about that? I'll add your stream to your screen share to the stream.
Yeah, I've been very fortunate. I reached out to a company called Instruct, who provide a interactive learning platform. One of the things that I'm trying to do with my courses and content is to bring that level of interactivity to it. It's really hard to do. And fortunately, they have agreed to let me do some tests on their platform. And we have what we see here is clustered 1 through 6. Each of these are clusters that I've wrote. Each of these is clusters where I have written all of the automation to spin up real kubeadmin, kubeadm based Kubernetes clusters. However, I've also written some automation that breaks them to pieces. And what we want to do today is fix them. So you can move and work at your own pace. You can work on these clusters in your own order, do whatever you want. However, I will be doing them in sequential order. So if you do want to follow along, see how to make progress when things get stuck, understand what I'm doing, why I'm debugging, I'll do my best to verbalize all of this as we go. And you should be able to follow along. And like I said, learn about Linux, operating Kubernetes, and deploying to Kubernetes. Now, the link to sign up, the rawcode.link/kubesimplify, is only valid for 24 hours. So you do have to sign up now or as soon as you see this session. If you miss the 24 hours windows, no, take a 24 off. Yeah, that's it. Thanks, Sam. If you miss the 24-hour windows, fear not. Please feel free to DM me on Twitter. I'll do my best to get you access to the clusters. Once you've registered, you do have a few days to be able to work through the exercises in your own time. The reason there are restrictions on this is just that Instruct is not a free platform. I can't have 100 million people signing up to it. So, we have to make sure that we do this and test it appropriately before we release it to the big bad wide world. So once you click on cluster 1, you'll see that you have 60 minutes on each cluster has one challenge. You'll see a start button here, whereas I see a continue because I already have it opened. So please click the start button. And what you will see is that it will take 3 minutes to spin up. So for the first 3 minutes of cluster 1, which I already have here, as you can see, I can type. This is a real Linux environment. I'll just cover some of the essentials of what you need to know to get started with each of these clusters, as well as the ground rules and, of course, your mission. What is it we're even trying to do with these clusters? What does working mean? So I'm going to cover all of that. So please click on a cluster. Probably makes sense to start in cluster 1 along with me. Click start, and in 3 minutes, you'll be ready to go. Let me just check the comments and see if I've missed anything. No, thank you, Sam, for sharing the link again. And Akash is asking for my LinkedIn profile. I'll show that towards the end. Don't let me forget. Okay, so the basic constructs within these interactive learning environments is one, you'll get a shell with a full Linux environment, and you can type any Linux command. You also get this web app page. Now, this isn't working. Right? This tells you that maybe it's just not ready yet. No, these are clustered clusters, right? They're broken. So this just means it's not working yet. Yes, please click clustered 1 learning tree. And Karthik, this is free for you to use today. Sign up is free. Just enter your name and email address and you can get started right away. So once we fix our cluster, we will actually be able to come here and you'll see a video of me. And we'll talk more about that as we make a little bit of progress through the first cluster. Now, because these are kubeadmin, kubeadm, kubeadmin is this command here. This is the definitive, official as it gets, way to deploy Kubernetes to any Linux machine. And in fact, kubeadmin is awesome. You can run kubeadmin init on any Linux machine, provided you have a little bit of setup done, which just means having the kubelet, kubecontrol, and kubeadmin installed. You can get a cluster. But what a lot of people don't realize is by default, you don't have access to this cluster. So normally, the way that we speak to a Kubernetes control plane is via the kubecontrol CLI. A very simple test to see if you have a working control plane or a working Kubernetes cluster is to run kubecontrol get nodes. This will list all of the machines that are part of your cluster. Now, what we see here with this error message is that we're trying to speak to localhost 8080 and the connection was refused. Now, this is what kubecontrol uses if there is no kube context. And we can see here, there is no current context set. And there's a whole bunch of commands that we can use on kubeconfig, and we can even run kubeconfig view. We don't have anything configured. Right now, we do not know how to speak to the Kubernetes control plane. Now, for all kubeadmin clusters, there's a magic incantation we can use. I say magic, it's not really magic, it's just convention, I guess. And magic sounds nicer. Where we can say that kubeconfig is equal to a file on our disk, and kubeadmin always, unless otherwise configured, creates all of the kubeconfigs for each of the special roles for the control plane components inside of /etc or etc/Kubernetes. So we have an admin.conf, we have the controller manager conf, we have the kubelet conf, and the scheduler conf. These names hopefully sound a little bit familiar to you. Those make up the majority of the Kubernetes control plane components. The kubelet, the scheduler, controller manager, and the API server. The API server is our admin.conf. So by setting our export here, we can actually run config view one more time, and we actually get a lot more information. We now have successfully configured how we speak to a Kubernetes cluster. And we can see that we're talking to a private IPv4 address on port 6443. And all of the secret information is redacted so that you cannot speak to my cluster. And if we run kubecontrol get nodes, you can see that we have a response from a Kubernetes API server. Okay, we have a question. It's stuck at setting up the challenge for the last 5 minutes. Now, setting up clustered 1 does take around 3 to 5 minutes. So just bear with it. It shouldn't be too long. Behind the scenes, Instruct is spinning up a Google Cloud Compute instance and running through a whole bunch of automation, like installing the Kubernetes control plane components, etc. So hopefully just bear with it, and it should start very, very soon. All right, so I'll check back in with you all in a couple of minutes, but hopefully you'll get there. Thank you, Sam. All right, so back on track. We have a control plane, and all it took to get there was to export our kubeconfig and run get nodes. Now, the most important thing here is that our status of our node is not ready, and that may or may not be bad. Generally, it's bad, but will it stop your workloads running? Maybe, maybe not. Kubernetes is a distributed system for running potentially distributed systems. So it's okay for components to come and go and to fail at times, and eventually they should become reconciled and consistent and operable. But sometimes that may not happen. So before we start debugging whether our node is ready or not ready, we can actually just check to see, is there other things on this cluster? Is there anything else that is an indicator that something may be wrong? We can run get pods. So what we can see with get pods is that we have a couple of clustered pods, but they're terminating. And we have a Postgres pod, which is stuck at container creating. we can add a dash capital A. This is the same as running all namespaces. And we can get a broader look across all the namespaces on our cluster. And now we can see that in the Kubesystem namespace, now the Kubesystem namespace is special. This is where our control plane and special processes live. We can see here that we have a running API server, which we probably knew because we're getting responses from get nodes and get pods. We have a running controller manager, and we'll discuss the responsibilities of these components if and when they break. But the controller manager is what makes it possible, or makes it is what is responsible for creating more Kubernetes resources that are children or descendants of other Kubernetes resources. Like when you create a deployment, it has to create a replica set and a pod. We have the kube proxy, which is responsible for writing all of our IP tables rules to each of the nodes within the cluster. And we have our scheduler. This determines where a workload or container or pod should run when we request it. Beyond the control plane, another vital part of all Kubernetes clusters is some sort of DNS resolution. If you're running an older Kubernetes cluster, you may see kube DNS here. But most, if not all, modern Kubernetes installations use core DNS by default. This just means that if we issue any dig curl commands that use a cluster.local, and that's configurable, DNS name, then they'll resolve within the cluster because of this DNS server. Next, we have Cilium. All Kubernetes clusters need to be able to communicate and send traffic. Yes, I can. Well, I'll zoom in one more, and then there might be some screens I have to zoom out a little bit, but I hope that helps, Canal. So Cilium is our CNI, our container networking interface implementation. That means that our workloads within the cluster can communicate with each other. Cool. So if anyone is still waiting, can you let me know before we move on to the next part of this cluster? Is everyone, hands up, hands down, got their exercise clustered one ready? So you've already found out what the latency is. Thumbs up, yes, ready, fire. Awesome. Okay, so let me rerun these commands in case you missed them. First thing you need to do, export your kube config. Point it to /etc/kubernetes/admin.conf. Once you've done so, this should allow you to run kube control get nodes. We should all be in a position where we see that our first node is currently in a not ready status. And here's a good top tip. When you run kube control get, you can pass more than one resource. Here, we can actually request nodes and pods together for a broader look at our cluster. We can see that we have our not ready node, 2 terminating clustered pods, and 1 container creating Postgres pod. So this is where we are. Things aren't working. Now, I said there was a mission for all of these sessions. The mission is the same for every single one. If you run kube control, edit, deployment, clustered, this will allow you to make modifications to the clustered deployment. Simple, right? And if we search for image, we'll see here that our image on a clustered application is GitHub Container Registry. So ghcr.io/rawcodeacademy/clustered:\v1. Your mission is to change this to v2. Now, you can do that now, but I am not, because I want to show you both the videos as part of this application. So I could update that to v2 and start debugging, but instead, I'm going to take a more methodological approach. And we're going to work out why we have 2 pods in a terminating status, why we have Postgres and container creating, and why our node is not ready. Now, before I start giving away all the answers and trying to describe my thought process, I'm curious about you. Does anyone in the audience have any ideas or indications of what may be wrong with this cluster based on what we see already? Now, these clusters are hard, so don't feel bad, don't feel worried if you don't. That's perfectly all right, right? Like Siam said, I've seen some shit. I've done a lot of debugging broken Kubernetes clusters, and I feel that my intuition is getting better and better with every one. That's true for everyone and everything, right? The more that we make ourselves uncomfortable and learn something new, the better we get at understanding that system. So, doesn't matter if you don't have any ideas, but if you do, type them into chat. Does anyone have any ideas what could be wrong with this cluster? All right, some great suggestions there. Russell, I'll come back to you. Okay, so Satindra image not available. Good guess. And that could be an error for us, especially on the container creating pod. However, when an image is not available, we do have a specific enumerated error, error image backoff, that will tell us the image couldn't be discovered or maybe authentication was missing. So in this instance, not quite correct. Avinash saying maybe the given node is tainted. True, we could have a scheduler problem here. And that scheduler problem means that we'd never be able to schedule a node to schedule a workload to a node. However, we do see container creating and we do have terminating. So if we had a scheduler error, we'd see pending as our status. And I'm sure we'll see that at some point throughout these sessions. Kumar suggested that the container D stock is missing and pods are scaled to 0. Yep, we'll come back to that as well. Image not correctly from Vishal. Scheduling disabled. All right, lots more ideas coming in here. So, all good guesses. Now, the reason I said I'd come back to Russell's is because these conditions are very, very symptomatic of a kubelet being stopped. Why? And what is the first indicator of that? Well, there are very few scenarios in which a container or a pod or multiple containers and pods would be stuck in a terminating container creating situation. Containers rarely get stuck in terminating because what happens after the default backoff period, which I think is 30 seconds, the kubelet will actually send a kill signal or a kill signal to the containers, and you cannot ignore the sig kill, which normally cleans up the pods pretty quickly. Now, there are cases where a finalizer could actually be blocking the release of that resource. But the other hint here is that we have another pod stuck in container creating. Now, the pod workloads being in these two states gives us enough information to make some deductions. But the cherry on the top here is the status of our node. There's very few things that will cause a node not to be ready. So how do we confirm suggestions that we have in the chat? Well, we can start to describe some of these resources. We can say describe node Kubernetes. And as pointed out in the chat by the learning tree, we have, container DE is not potentially available. In fact, it looks like here the kubelet is reporting an error message. So Russell, you're close, but not quite close. Because if the kubelet is able to report these messages, then the kubelet is potentially, and we'll confirm, running successfully. However, the kubelet is unable to speak to container D because the socket file that we expect to exist is not there. All right, let's describe one more thing. Let's describe pod Postgres. Okay. Now here we do have an error image pool status. However, it's because container D, again, we're not able to communicate with container D. And what's responsible for pulling in images to our machines? Well, it's the container runtime interface. So container D is responsible for going to the registry, getting the images, and keeping them or pulling them locally. So a whole bunch of information being thrown at you here, but hopefully you can start to understand some of the symptoms and what those mean within the context of a Kubernetes cluster. And again, this is through repetition and trial and error. The more that you debug these clusters, the more your intuition is going to improve at pushing these error messages down to something else. So let's run kube control status kubelet. All right, Russell, you were super close, and 9 times out of 10, I think it would be the kubelet, but unfortunately this time our kubelet is working. You can actually see here we have some error messages from our kubelet service. If you're not familiar with Linux, you can use journal control. My favorite flags for journal control are flu, so -flu. Pass in the kubelet, and we're going to start seeing container D, container D, container D, container D, container D. So let's check container D. You can do that with system control status container D. Now, depending on whether your terminal has colors or not, this could actually look like it's working. You know, you could see here loaded, enabled, and enabled on this first line. Those are good messages, good indicators. However, on the second line or the third line of the terminal, at least, you can see that this service is inactive and dead and has been for 29 minutes. So the problem is that some random operator, my terrible automation, has accidentally disabled container D, maybe for routine maintenance, who knows, but they forgot to start it again. So you can fix our first symptom with system control start container D. And we're going to give that just a few seconds. Okay. Run get nodes. I didn't give it enough seconds. Eventually, get nodes will report that is ready. And if we run get pods, oh, we're not quite there yet. In this case, the kubelet might take a little bit of time to realize that container D is there again. You can actually encourage it with just a quick restart. So we're going to give kubelet 5 to 10 seconds to start speaking to container D and updating all of the statuses within our cluster. Now, we have a question from Samarth in the chat. Container D is equivalent to Docker running on the host. Well, yes. Before container D, the default CRI implementation within a Kubernetes cluster was Docker. But Docker itself used and has done for a long time container D under the hood. So container D actually started at Docker. They wanted to break down their application into multiple components as part of the Moby transition, I believe. Maybe container D dated that a little bit, actually. And container D was spun out. Also we had another component called runc. So container D was like a daemon to handle operations of containers, and runc was the actual executor for running containers on the host. And we have a whole bunch of shims that work and talk to Docker and other things. That all gets very complicated very quickly. But you can almost, at least a few years ago, say container D and Docker had very similar responsibilities. These days, Docker is not the default runtime in a Kubernetes cluster, although the people at Mirantis do maintain a working Docker CRI implementation. So yeah, kind of a true comparison, but the responsibilities are differing the longer and more as time goes on. Much better. Okay, so we gave the kubelet and container D a little bit time there, just as I was talking and answering the question. We can now see that our node is ready, and we actually have a running Postgres instance, which is fantastic. However, we don't have our clustered pod. Where is our clustered pod? Well, we can start to understand our cluster a little bit more. Now, pods are generally not something you deploy yourself, right? Why? Because the pod spec is mostly immutable. It's actually near impossible to modify a pod. You have to spin up a new pod. So we need primitives to handle that. Pods are actually created by replica sets. You can run kubectl get rs or replica sets. Same command, just short syntax. And we can see that we have 2 replica sets. Now, why do we have 2? Well, whenever we make a change to the parent of the replica set, and concepts into middle is correct here, the parent is the deployment. Whenever we make a change to that deployment, it actually creates a new replica set, and then that replica set will create new pods. And then when that new replica set has enough healthy pods, it will begin to terminate and shut down the older replica set, giving you, in essence, a very crude implementation of a blue-green deployment, but without enough automation to actually make sure that it has the same characteristics that you would expect from a blue-green deployment. However, there are many add-ons for Kubernetes that give you those extra constraints and operation stuff. But we can see here that both of these replica sets have zeros all the way through. Desired 0 pods, current 0 pods, ready 0 pods. And then the same down here. So we can actually run get deployments. And we'll see here that we have ready 0 of 0, up to date 0, available 0. Does anyone know what this means? And I actually seen this comment earlier on. Where was it? I was sure I seen somebody mentioned this, right? Oh, did someone? I see message. I'm not sure. Okay, I thought someone mentioned that it was scaled to 0, but that is correct. This deployment is currently not configured to run any pods. There's a whole bunch of ways to scale in Kubernetes. You can use the kubectl scale command, like so. So we can say kubectl scale replicas equals a number and then the resource that we wish to scale. So it could be deployment clustered. We could scale an individual replica set if we wanted. It's up to you. However, I prefer working with the YAML because I mostly do GitOps on my clusters. So I make modifications to YAML, I push them to Git, the cluster gets eventually consistent, and I'm happy. When I'm doing interactive, I do prefer to work with the YAML too. So for right now, we're going to say edit deployment clustered. If we search for replicas, you'll see this line here on line 20, that is actually set to 0. So we can replace that 0 with a 1 and save. And if we run get deploy, rs, and pods, we'll see that our deployment now has 0 of 1 ready. Our second replica set has desired set to 1. So our old replica set will not be updated because we've already migrated to the new one now. That's fine. That's expected. But we have a pod with an error image pool. And we can see here that our clustered application, we need to understand what is actually happening here. So we're going to run kubectl describe pod, and we can just copy the pod name and hit return. And this is going to give us a whole bunch of information. Now, when you describe a pod, you get to see all the metadata at the top. So we've got the name, namespace, priority, service accounts, nodes, labels, blah, 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 blah. We get all of the container specs. We get all of the conditions and status and events. Now, there's one error message on this that is a very big indicator of what has went wrong with this cluster, but I'm not going to give it away. So for the next minute or 30 seconds to a minute, if you see something here that you think is the root cause, paste it into the chat. And even better, if you think you know what the issue is, drop it into the chat. So 30 seconds, off we go. Now, this is a hard one and a tricky one. This is not an error that would typically be made by mistake. This is a definite break in the clustered sense of things. However, networking is hard, and these things could actually happen via reverse proxy implementations and a bunch of other misconfigurations. So we'll try and discuss this. But I want to know if anyone knows what error message is important in the events here. Hopefully you've picked up on that already. Spot on again, concepts and Tamil. It is a certificate issue. Do you know why? Okay, Avinash has went with authorization to pull. Not in this instance. Canal says image pull back off, unable to pull. It is unable to pull, yes, but not because of authentication. Kumar, not ghcr.io. Perfect. That is exactly the problem. So let's cover that. So you all did really, really well there. This is the main error, okay? So we can see that container D, through the kubelet instructs container D, which is why the from is kubelet here. But the kubelet is telling container D to pull an image for us. ghcr.io/rockwoodacademy/clustered vu1. We get an error message, which is we failed to resolve the reference. Now, what's interesting here is this error message doesn't say, I don't know this API. I couldn't find an image. I had authorization problems. It's telling us that the X509 certificate that we got for this manifest or this URI is not valid for ghcr.io. And actually, it is valid for Docker, DockerCon, Docs Docker, Docker.io, but not ghcr.io. And that's a really important bit of information. Now, I said this is not like a regular production break, but a lot of people do like to run pull-through caches, especially in their clusters, which could have limited networking capabilities to the outside world, restricted egress traffic, or perhaps you're trying to minimize your ingress costs by not pulling down huge images from the external internet all the time. So running a pull-through cache is actually a really nice way of doing it, and that could lead to misconfiguration. However, in this instance, it is malicious intent. I'm going to give you one more clue and 1 more minute to guess what this error is, and then I'll reveal what it is. Okay, so I'm going to do curl ghcr.io. And we're going to make this verbose. And you'll see we get a very similar error message. So it says that there's no subject alternative name for GHCR on the certificate. And I'm sure if I add another flag, I'll see the certificate, but I'm not fussed right now. And one last thing is we will run host ghcr.io. I would encourage you, if you have a Mac or Linux or Windows with some sort of Linux command line or core utils, to run host GHCR on your own machine and see if it differs from what we have here. And if you have any ideas of how we can manipulate that DNS resolution within a Linux machine, feel free to drop it into the chat. Again, I'll give you around 1 minute before I give you the answer. And we're almost finished cluster 1, and we'll be moving on to cluster 2 very, very soon. Kumar, you are on the ball. So, Kumar's correct. There are many ways to manipulate the DNS within a machine. Of course, you can configure a systemd, resolved to work and do your own bidding. You can run your own DNS servers within your own data centers and point it to it. But the crudest way that developers have been doing for decades is to manipulate DNS resolution inside of our host file. So we're going to remove that. Maybe we had that set up for debugging. Maybe we're testing whether we could pull things from Docker Hub instead of GHCR. Now, there are ways to mark curl requests to accept insecure certificates, and there are ways to make sure container D can pull insecure certificates. However, we're not going to allow that today. So remove that last line and hit save. We have to encourage You're able to try this again without waiting up to 4 minutes or whatever the backoff is at now. So we are going to delete the current pod, which is stuck in an image pull backoff. Now we have container creating. I'm going to run kubectl watch -w. The -w puts us into a watch. The API server is going to push any changes to these resources down to our local kubectl command. And we should see that once this Kubernetes instance has pulled the image, hopefully, we progress from container creating to a running pod. And in fact, right on cue, we can see now that Klustered is running. So I said the mission is to upgrade from V1 to V2. I believe we're now in a position where we can see that change in our application. So we have a Kubernetes pod running. So if we pop over here and hit refresh, it's still broken. So perhaps we have one more thing to debug. Now, I'll tell you this, and again, I'll give you 30 seconds to throw some ideas into the chat, and I'll answer a couple of questions. In fact, concepts is all over it. Thank you. Our web app here is configured to hit a node port service on our machine. In fact, in the interest of time, let's just work through this. So we haven't actually worked with services yet, so let's do this. We can do kubectl get svc, and this will list all of our services. And we can see here that our clustered node port service is exposed on port 30,000, and somehow we need to, or it's going to route traffic to port 80 in our container. I'll give you one hint. If we run a kubectl exec it and jump inside of our clustered pod, our localhost on port 80, it will not work. Our application actually doesn't listen on port 80. So, since these are all doing very well at working out what is broken here, how can we take an arbitrary pod and understand the ports that are bound on the TCP stack? Anybody got any tips on how we can understand, without going and speaking to the developers, who could be in a different time zone, they could be on vacation, they may be just slow to reply. How can we just go and answer this question for ourselves? What port does our application run on, and how do we work that out? So I'll give you 30 seconds, maybe a bit longer. Wow, consensus is in. Right. So, Kumar said probes. So, just to take a look at what what Kumar means by probes, let's describe our pod. In fact, maybe we'll get a YAML. Although I don't know if I added any. Pod YAML. Okay, there are no probes here, but there is something I want to talk about. So yeah, if our pod was running, it would have some sort of liveness and readiness probe potentially on it. This one doesn't, but in production, you would hope that it would. Those probes may be an indication, because they're passing, of the port your application is running on. However, we can't use that today, but very good shout, Kumar. We then got 1, 2, 3, 4 shouts for netstat, and that's a fantastic suggestion. Samar with get endpoints. Now, I love that you've mentioned endpoints. However, the endpoints are indicative of the service configuration rather than what actually runs in the cluster. So not quite going to work in this case. Karthik says LSOF, or yeah, we could use LSOF. Why? Does anyone know what LSOF does? it lists open files or file descriptors. And bines and ports. In fact, everything in Linux is a file. So if you want to know whether something is actually listening on a port, yeah, you can use LSOF. The consensus was to use netstat. So you could say, well, let's run that. Oh, and you will have to install it. But there is an easier way. In fact, there's a couple of ways to do this. There's a couple of fun ways and there's a couple of other ways. But we could run netstat and we could go through all these ports and see if we see what we need to see. Do I see what I need to see? I do not. Okay, LSOF. Let's try this. -I-p. These are not the ways that I do it, so I'm just going to go for this. Let's see if I can see what I need to see. This does not reveal what we're looking for. All right. Were there any other suggestions that I missed? I don't think so. Okay. Everything in Linux is a file. So let's run get pods. We're going to do an exec inside the Klustered, and we're going to run bash. From here, we can take a look at our process table. You can see that our process is running HTTPD. Now, this could be Samarth asking what we're looking for. We're looking for the port that our application runs on. So we can see here the command is HTTPD. So we could now actually grep for HTTPD on the host process. This gives us more information that we can use with more host commands, which means looking at netstat LSOF and trying to filter it by process, which might reveal a little bit more. However, when we're inside the container, we can actually do cat proc self. And in fact, let's do an ls on that first. Everything in Linux is a file, including the proc file system. There's a special link /proc/self, which will give you information about the process that is currently running. Well, that's not going to work with them in a shell, but oh well. We could do proc1 because our application is proc1. How do we get that? Well, PID here is 1, and we're inside the container. We could also do this on the host. So if I do that PS again, we could do a ls proc and copy the process ID from here. Either way, we're still getting the procedural or proc file system for this application. From there, we have a net folder, and we can get a whole bunch of information from in here. So you can actually process this to work out if there are any sockets that are bound on a port. Yeah, I'm trying to remember what file it is now. Let's try sock. Let's try TCP. Yeah, there we go. Now, this is not the most friendly thing to read, but actually this local address is our bind address. And 029A is actually a hexadecimal number. And if you convert that hexadecimal number to a decimal number, you will get the port number that our application is running on. Are there any other ways to do this? I'm a big fan of eBPF. So if I do an app search for BCC, what's it called? Yeah, tools. Search for BCC. I always forget the name of this package. BPFCC tools. Okay. Let's install this. But I know I'm moving quite fast through this last little bit. But getting the port number, there are many ways to do it, and I'm just trying to highlight some of the cool ones. Now, once we have this installed, we can run ls-l user local bin. Is this going to work? No. Maybe it's user bin. But let's do a witch on open. which will show you where our command line is, because I don't know where these are installed by default. We can then do user sbin ls and grep for snoop. Now, why am I grepping for snoop? Because BPFCC tools is a set of eBPF programs that allow you to interact with the kernel to pull stuff back out. Now, not in fact, all the snoops aren't actually listed here, so they must live in multiple locations, but I'm going to cover a few of them anyway. The first thing you can do is use the snoop tools to discover all open files on a machine. Use the snoop tools to discover all commands executed on a machine. And use the snoop tools to identify all TCP sockets and a whole bunch of other stuff. So if there's anything on a Linux kernel where you want to understand file, networking, syscalls, it's just all available to you. In fact, let's run OpenSnoop. Every time, there's going to be a lot of information here. Every single time a file is opened on this machine, you're going to see it listed here. Whether that's a process doing an fopen, where it's a shell doing a cat, where it's a subshell doing, I don't know, reading a file in to spit it into another process, any file open or anything that accesses the disk, we're going to see it here. And in fact, we can see that the kubelet is reading the core file, so that's our core DNS pod. We can see that something used our resolve conf. So OpenSnoop is really cool. We also have execsnoop. This will show us every time a command is executed on this machine. Let's kill that now. You can see our probes from all of our Kubernetes pods. So the Postgres pod that we're running actually has a recurring probe that runs PG is ready with this information. So we can see that in real time. And in fact, I could even run execsnoop, send it to the background, and then type wall hello, FG and quit. So that was fast, but I ran execsnoop, detached from it, ran a command, pulled it back, and then killed it. Now we can see that I ran. How quickly was I? Yes, I ran wall hello here, and then execsnoop picks it up here. So you can see wall command, process ID, parent process ID, the return argument, the command that was run, absolute, as well as the arguments passed to it. So the snip stuff is awesome. Excuse me. Okay, last TCP. Oh, that one crashed. All right, we're not going to worry about that. There is the TCP connect thing. Maybe it's broken on this machine. I'm not sure why. This will actually show you every time process starts listening on a port number, which would reveal the port number for our application. Okay, that was a lot. Did I miss anything in the comments? Russell saying this is new. I've not seen proc used for network discovery before. Yeah, the proc file system is great for this stuff. And also something that not a lot of people know is that you can actually do Bash has its own networking stack to the point where you can actually send you can replicate netcat by doing bash to dev TCP net. I'm going to ruin this now. There's a bash interface for sending TCP connections to URLs and port numbers, which works if you don't have netcat, but you do have bash. I can't remember the syntax, but you can look that up. It's kind of cool. All right, Kumar saying you could use TCP dump. 100% we could. Russell saying we could use Nmap or Rust scan. Yes, but it would be slow. Scanning ports is very slow. Virendra asking, does this come in Red Hat? eBPF and those Snoop tools work on every single Linux machine that is relatively modern. I can't remember the exact version, but yes, it just works. And what is the package name for that? Just search for ECC. And also, you don't really need a package for this stuff. You can come to GitHub IO Visor BCC. all of those Snoop tools are actually in this repository. So if you go to github.com/iovisor/bcc, and then just search for one of the snoops. So I'll just do exec snoop. You'll see there's this tools directory, and then you've got some example text, the man page, and then the code itself. So these are all really simple things to implement. And then Python wrappers if you need to be able to do it in Python. So yeah, iovisor BCC, really cool way to check this all out. Okay, let's fix this cluster and get moved on to the next one. Don't know if anyone decoded the 29A. I didn't see it in the chat. At least I hope it decodes correctly. Let's see. Hex to decimal. Let's see. 029A. You'll see here the decimal version of that is 666. So we want to come back here and edit our service. Then I'm going to point out one more thing that is really annoying in Kubernetes, and then we'll move on to cluster 2. So I'm going to remove the target port. We don't need it because it's not different from the port. And we're going to update our port to 666 and hit save. Lastly, I'm going to edit our deployment just to show you something, not to make an edit. Inside of the pod spec on all deployments, thank you, Sandeep, for the conversion as well. Inside of all pod specs, we have this ports, which says container port, name, and protocol. These are 99 times out of 100 useless. There's no enforcement. There's no guarantees. They don't actually do anything. Nothing. So you may have thought, well, I can go look at my deployment spec and see what ports my application says. But it's hornswoggle. I can set this to anything I want. It doesn't really do anything. You want to know what it does? It means that in your probes and your services, you can use a mapping. That is so frustrating. I'll restart it quickly and I'll fix all the errors. It provides a mapping where you can reference the name and it'll map it to the port number. So there's actually no semantics, no guarantees, no constraints by providing that container information. It's only if you want to reference your port numbers by some sort of arbitrary label in other parts of the Kubernetes ecosystem. All right. I'm going to start number 2 just now because it does take a little bit of time. And hit launch. So if you're with me and you're still here, go to cluster 2 and hit start. And I'm going to walk you through fixing cluster 1. That last bit, in fact, we probably don't really want to wait for me for 3 minutes. We'll see if it's quicker. But you can actually modify your cluster deployment, change the image from V1 to V2. And if you go to the web app, you'll see V1, I'll be tapping my watch. And on V2, I'll be doing a dance. Now, the mission is the same for all the clustered sessions. You want to upgrade that image, go to the web tab, and see me doing a dance. So, to save us a few minutes, if you could all do that, and if you see the dance, post into the comments, and I know that I don't need to quickly fix clustered 1 again. And your sessions shouldn't time out. All clustered workshops or all sessions, you get 1 hour to fix the cluster. I just spun up clustered 1 in advance, which is why I ran out of time. So has anyone got the dance? Please tell me you got the dance. Nobody got the dance. Nobody. All right, I guess we'll wait for my session to pop back up and I'll quickly run through those breaks, but it should only take me 2 minutes. Does anyone see the watch at least? Come on. Give me something in the comments. Am I still here? You've all gone very quiet on me. I'm starting to worry. You can still hear me, Siam, right? Yeah. Okay, there we go. All right. So Kumar said that they changed the deployment container port. Did you change the service? Remember, you have to change the service, remove the target port, change the port to 666. Thank you, Sandeep. All right, you did change that, Kumar. Okay. Really wish my session hadn't expired. Yeah, good comment from Siam. If you run kube control get endpoints, do you have endpoints for your service? Oh, I think there actually is one last break related to that. Thanks, Siam. All right, we're back up. So I'm going to fix this in lightning time. Oh, that's the speedrun edition. Host file break. Oh man, too. Oh, don't do that to me. Is this the right one? Yeah. Okay, export kube config. Control, system control. It is container D, inactive, start container D. I'm going to speed that up, restart the kubelet, run get pods on a watch. We'll see that coming back up in just a second. Yes, you will have to either delete the target port or update it to be the same as the port. I can see my kubelet working now. I'm going to run get pods. All right, I'm going to scale my deployment. So I'm going to run get services and endpoints. I'm going to edit my service with the updated port number. So we can just say 666. And the reason we could delete the target port is because it's the same, or we want it to be the same as the port. I can run service and endpoints again. And okay, we do have one last thing to fix. So whenever we see that our endpoints is none, 100 times out of 100 times is always the same thing. We can do describe SVC clustered. So the way that services work is that they have a selector which has a label key value pair where it says app equals clustered. Now this has to match our pod spec. We can describe our clustered deployment and we can see our pod template has labels app equals clustered. Now, in the interest of time, I'll just say this is a typo. We can edit SVC clustered, come down to our selector, and we'll see that we're missing an E. Save our service. And I call this get the Holy Trinity, pods, services, and endpoints. If you ever need to debug any application in Kubernetes, these are the three things that you always want to see. And we can see that we now have an endpoint. And if we pop back over here, we'll see that we now have the watch tab. This is video 1. So now we need to upgrade this to video 2. So the last step is kube control, edit, deployment, clustered. We're going to modify our image. E2. Run get pods on a watch again. See it's running. And if we pop back over here and hit refresh, we have the dance. So objective complete. Cluster 1 completed. We can move on to cluster 2. So I hope you all have the dance. I hope you've all successfully fixed our first cluster. And we're going to lead nicely into clustered 2. Now you can check all of these clusters by clicking the check button. If you have successfully deployed the correct image, it will say well done, and you can click finish. I'm now going to pop over to our second cluster. Give me a thumbs up when you're ready for cluster 2. All right. Looks like a couple of you are ready. Thank you, Avinash and Canal. So, again, on cluster 2, we're exporting our kube config. This is a kubeadmin cluster. We have to do that at the start of every single cluster. Next, we can run kube control get nodes. We see that we have a control plane. And we can see that our control plane is ready. Next, we can run get pods. You see that clustered and Postgres are happy. This cluster looks to be quite good. Vishal asking, the last part went very quickly. Yeah, sorry, I had to refix that entire cluster because my session expired. The only fix, as Siam is correctly saying in the comments, was to fix the service label. So it's app equals clustered instead of clustered D. And that will fix it. Instacane, what's the website you're running again? This is on instruct.com. If you want to get to it, you can also go to rawcode.link/instruct. And that gets me a referral point, which means I get to make more of these classes public to people. So if you're feeling very generous and kind and want to help me out and make more of this public to people, rawcode.link/instruct. Okay. Yep. Let's go for it. All right. So this looks good. So I'm going to go straight to the web app. Oh, dear. It's broken. Now, there's a few things here. First, we haven't seen this error message before. Second, we have got a response. So that tells us a few things, right? It tells us that our deployment is running, our service is configured correctly, and we can actually reach it. So our application is sending us a response. Most of our boilerplate and plumbing in this cluster is working, right? So this is great. This means that the surface that we need to be able to debug is much smaller. Next, we need to really understand the error message. Now, it's very easy to see failed to connect to a database. I start jumping to lots and lots of conclusions. Okay, where do I go here? What do I need to fix? But it's always important to pay attention to the error messages in full. So what we can see here is that we have an error connecting to the server, and it actually failed to look up the address information. And as a response of a result of that, we have no DNS resolution. So this one is potentially a DNS issue. So we come back here, and in the interest of taking a nice look at the entire cluster, We can see, well, Klustered is running, Postgres is running, Cilium is running, and Core DNS is running. So everything looks interesting, or at least looks good. So I'm going to give you 30 seconds in the comment section. What could potentially cause our DNS to fail inside of a Kubernetes cluster when everything does appear to be running? All right, you have 30 seconds. Drop in your ideas. So we got service name and service discovery issue. Okay, we can confirm. Now, I know this application and you do not, so I will confirm one thing right off the bat is the Rust-based application that displays the videos and the error message is hard-coded to speak to a service called Postgres. This service here. So, we've got Instacade and Russell and with Core DNS as well, which I'm going to also relate to service discovery issue. Let's see if we can confirm that. Now, we can use kubectl exec, jump into a pod. Why am I jumping into a pod? Because this allows me to use Kubernetes networking to try and replicate the issues that we're seeing on the customer-facing side. From here, we could do an apt install DNS utils. Find utils. Oh no, I need to do an update first. Oh, that's interesting. What does that tell us? First one in the chat to get it right wins a t-shirt. Yep, a cache saying we have no connection. Yeah. We have no internet connectivity at all. We don't even have root, but that's all right. Yeah. However, our host does. So, who's got an idea? I'm only going to give this 30 seconds and then we're going to start. Avanash. Perfect. We have potentially a network policy issue. And the chances are we've lost egress in our cluster. Almost as if you've seen this before. So there are a whole bunch of ways to configure network policies inside of a Kubernetes cluster. There's the networking v1 implementation, which is just Kubernetes vanilla networking policies. We're also running Cilium in this cluster, which means we have access to Cilium network policies and Cilium cluster-wide network policies. So in order to debug what is potentially happening in this cluster, I'm going to run a kubectl get for all three of those resources. And before I run that, if you're ever unsure what's happening or available within your cluster, run API resources. Kubectl API resources lists every resource definition in your cluster. Rep net. And we'll see we have network policies, Cilium network policies, and Cilium network wide or cluster wide network policies. So we can run netpol, CMP, and CCMP. API resources also shows you the shorthand syntax. So instead of typing Cilium cluster-wide network policies, you can type CCMP. Instead of typing Cilium network policies, you can type CMP or Cilium MP, etc. And we'll see that we have one. I love the naming of it. I was feeling cruel that day, maybe. But you'll see that we have a networking v1 allow egress network policy. So why don't we take a look at this network policy? And we're going to look at it in YAML. So we'll just do get netpol. And we get this type. Now, the reason I like showing off network policies is because visually, to read the YAML, they don't reveal an awful lot, at least when they're abused in this kind of way. Like here, we can see this network policy has a pod selector, which is empty. Is that all pods or no pods? Who knows? Okay, this policy is going to affect egress. Okay. How? This actually passes your eyeball test. Like I look at this all the time and I'm like, yeah, nothing wrong with this policy. This policy is great. But it's not, because you have to understand that the default network policy is to deny all. The empty selector is a select all, and our policy type is egress. So we're denying all egress by default. Now, this is something that you learn through trial and error and pain. So while we're here and doing this session, I'm going to encourage you all to go to editor.cilium.io. This is my favorite resource for taking network policies and trying to understand how the hell they work. You can come here. Goodness, do I have to upload? Yeah. Let me open a terminal. I wish they would let you type all.yaml. I'm going to paste our exact network policy, move it into my downloads folder, and I'm going to upload it. Now, we can see this is the same policy. Drag this down so that we can make this bigger. Hope that's all right for you. And we can see here that in our default default namespace, we have this egress default deny. So now we have this visual interface that explains that YAML to us. And in fact, if we drag this up a little bit, yeah, there's our egress type here. Now we're talking about the selector. Well, look, it's selecting everything. It's any pod, any endpoint outside the cluster. So all egress, all traffic, and it's everything in the cluster. So we're not actually allowing DNS. And we actually have this nice little indicator here that says, hey, maybe you want to allow this. So we can actually allow DNS. And this modifies our policy for us. So it's like, hey, actually, we have some egress. We want to allow all UDP port 53 traffic to kubedns. So the Cilium editor is a fantastic tool. I encourage everybody to use it whenever they're working with network policies. You can use vanilla network and V1 network policies or Cilium's custom network policies. These are, I would use the Cilium custom ones if you want to do anything L7 and keep everything else at L4 and Kubernetes V1. That's a heuristic that I use personally. Not a catch-all, follow this as dogmatic as I say, but it's a good starting point at least. So let's jump back to our challenge. I could fix this. I like Siam's advice earlier on. Just delete the policy. So for today, we will delete it. If you want to try this again tomorrow or later on today and you have a bit more time, why not see if you can actually make that network policy satisfy all the traffic that we have, which we did by one click of a button to allow DNS. The one other rule we would need is to allow port or TCP traffic on port 5432 to our Postgres service. So it's 2 more lines of YAML. Feel free to check it out and try it if you can. But in the interest of time and today, and because this is live, I'm going to delete allow egress. If we pop back to the web app and hit refresh, we have version 1. We have the tap of the watch. Okay. Edit our deployment. Avinash, where is my t-shirt? Well, you did say network policy issue, so if you can drop me a DM on Twitter, I will hook you up with a t-shirt. All right, let's save v2, and then we're going to run get pods on a watch. Nothing is happening. Drats. We have not fixed our cluster just yet. I'm going to run get deployments, get replica sets, and get pods. I want to understand when I saved my deployment, did the changes propagate down the hierarchy that I expect? So we can see here our deployment has 0 of 1 ready. We can see on our replica sets that our old replica set has 1 of 1 not ready. But we can also see that our replica set was created 16 seconds ago. So when we modified our deployment, the deployment controller detected the change and created our replica set. However, no new pods have been created. Now, this is a difficult one if you haven't operated Kubernetes before, but I'm going to give you 30 seconds. How is this possible? What could cause this effect? Hey, Rohit, how's it going? So, any ideas? Ten more seconds. Last call. Yuvraj, interesting. Resources, yep, it could be. Definitely. Siam saying scheduler. Good call too. Could it be? Could be. No one else? Okay. So we have two hypotheses. We need to be able to confirm that, right? So when we have resource crunch, as called there, or constraints, you can describe the node. From here, you're going to see error messages telling us if we have any issues with potential quotas and resources or overcommitment. And excuse me. Actually, this cluster's fine. We're not at the point where workloads are not going to be run or scheduled or blocked by any resource constraints. We would, of course, see that information on the pod if a new one was spun up. This is also why it's not the scheduler. Nice try, Siam, but not today. If this was a scheduler, we would see a new pod, but the pod would be pending because it was not able to be scheduled somewhere. So, good guesses. And some of them may be true soon, but right now that is not the case. So let's understand the hierarchy of a Kubernetes deployment. Now, when I ran get deployments, replica sets and pods, right? This is the hierarchy of how we get to pods when you use a deployment. And what happens in the Kubernetes API is we apply a deployment to the cluster, the API server, which writes it to etcd. There is a watcher on etcd for all deployments by the deployment controller. And the deployment controller's job is to create new replica sets when the deployment spec changes. Well, depending on which part of the deployment spec changes. Coincidentally, when a deployment controller writes back to etcd for a new replica set, there's a replica set controller. That replica set controller monitors for new replica sets or edits to current or existing replica set and creates pods. So we have this layer of controllers all the way down. And what we have here is an indication that one of those controllers is not running. So how are controllers configured in a Kubernetes cluster? Well, it's important to note that this is a kubeadmin cluster, right? I keep saying that because there are a lot of conventions with kubeadmin clusters that are really important to understand. And one of them is that the control plane runs as something called a mirror. Last time I said this in a country that wasn't Scotland, people didn't understand me. Mirror pod. Mirror pods are created by static manifests by the kubelet. And Siam's already noticed what is wrong with this. Good catch, Siam, in the chat. So all static manifests live in by default, etc Kubernetes manifests. From here, we can see that we have some control plane components. We have the API server, the controller manager, and etcd. If we want to modify the controllers, we can modify the controller manager YAML. This is a Kubernetes component that decides how we run what we want to run from the core controllers. And as Cyan pointed out in the chat, we have this line here on line 21, -- controllers. Now, this is interesting because what we actually have is a star that tells it to run the default controllers. We then have bootstrap signer and token cleaner. But then on the end, we have replica set. Now, this does not mean run the replica set controller because it starts with a hyphen or a minus sign. This actually tells it to remove the replica set controller. We can actually delete that and the trailing comma and save this. Now, with static manifests, the kubelet will detect changes to this on a regular interval and start to reschedule the controller manager and encourage it to restart with its new configuration. Of course, you can monitor this with PSAUX. And in fact, we can see that this is already restarted based on this timestamp, which is now. So that's just the UTC time where I am at the moment, or actually BST, but irrelevant. So our control manager has restarted. And in fact, we could trace the flag all the way down on this PSAUX where we could see controllers here. And we'll see that it no longer has the minus replica set. So I'm really confident that running get pods now will show our extra container. And now we see the pending. So maybe Cyan wasn't wrong after all with his first guess. Because what does pending mean in a Kubernetes context? Well, 9 times out of 10, it means we have a problem with our scheduler. So if we describe this pod, see that there actually is no error message. All we have is status pending. And again, these are all errors and situations within a Kubernetes cluster that I think are fun because they highlight some of those cracks in the observability or understanding of Kubernetes. There's no error message here. There's actually nothing to tell us this is unscheduled. In fact, the only thing that really reveals anything is this node is set to none. Sorry, my highlight pops my sidebar open. There we go. Is that our node is set to none. And unless you know to look for that, it's very easy to miss. So why don't we have a scheduler? Well, you're on PSAUX again and grep for schedule. Nothing. And if we look in the static manifest directory, we actually don't have a scheduler YAML. This cluster has no scheduler. So the way to fix this would be to, go to a working cluster, get the manifest for the scheduler, create it in this directory, go to Google, search for kubeadmin scheduler config, and put it in this directory. But there's one other way that I always love to use on Klustered, and I'm going to use it today, which is the scheduler as a control plane component doesn't actually do a lot. And that's actually a lie, right? It does do a lot because it's looking at resource constraints and scheduling affinities and intents and all this other stuff and working out the best place to put your workload. But the output of that is really simple. So in order to bypass the scheduler, we're going to edit our deployment. Stop. You don't need a scheduler in some situations when things are broken and you just want to get them working. We're going to modify our deployment spec to force this pod onto a new machine. We have the deployment spec, which has a template. This template describes all pods that will be created as a result of this deployment. And pods have a spec too, which lists all of the containers and probes and policies, etc. There's one more field that we can add to a pod spec, and that is node name. We're going to save this as Kubernetes. Now, before I run get pods and go check for the image, I want to share one more thing. How does anybody know all this crap? There's a really, really cool Kubernetes command line called kubecontrol. It has an even cooler subcommand called explain that most people overlook. When you run kubecontrol explain, you can pass any resource. and you get the Open API documented spec of that resource. So for here, you can do a kube control deployment. And if you remember the tree that I was working through in that YAML, deployment spec, pod template, pod spec, it shows us every field that we can set on our pod spec. Now we know the name, so we're going to do .node name. And this tells us the node name is to request to schedule this pod on a specific node. So we can just encourage the kubelet to run this pod and bypass the scheduler altogether. And in fact, we can confirm by running get pods, and we'll see that we have our new clustered pod created as of 64 seconds ago. Well, let's pop open to our web app, hit refresh, and hit play. We have the dance. So, if anyone has any questions on Klustered 2, drop them into the chat. So concepts is asking, so internally, all the scheduler is doing is to add a node name to the pod spec in the background after selecting the right node as per its logic. 100%. You can write your own scheduler and probably 30 lines of code, but it wouldn't have all of that logic that the Kubernetes base or default scheduler has. So, it actually does do a lot. It checks the resource request limits for the workloads that it wants to schedule. It checks for affinities and taints to make sure that it has that, if it can't be scheduled next to its friend or it needs to be, handled in a different region using the node topology rules. There's all of this logic built in, and it will put it somewhere. But the output of all of its logic is that one property on the pod. So if you ever need to bypass your scheduler for whatever reason, it's very easy to do so. All right. If there are any more questions, pop them in the chat. I'm going to start spinning up cluster 3. And we don't have a lot of time. I will do my best to get through it. And if I need to run through it myself, I will. But I'm hoping I can take you all with me. So cluster 3, start, and launch. And we're not going to have time for 4, 5, and 6. So please feel free to do that in your own time. And if you run into any issues or you're not sure how to fix it, I am available on Twitter and always happy to give you some tips or advice. Okay, so Vishal asked, can I please elaborate on the Kube Controller Manager changes? Yes. The Kube Controller Manager is a set of controllers that monitors for that monitors for resources or changes to the desired state within your Kubernetes cluster and will reconcile them whenever possible. So by default, there's a deployment controller that monitors for changes to deployments. When required, it will create replica sets with those changes. And then there's a replica set controller that creates pods. There's also a pod controller that does poddy stuff too. On that controller's line, you basically always want to run the default controllers, otherwise you don't really have a working Kubernetes cluster. However, it does support disabling those controllers, and that's what happened in this instance. Some rogue operator, me, added -replica set to the controllers list, which actually told the controller manager not to run the replica set controller, meaning we didn't have a controller sitting monitoring for changes to replica set resources and in turn couldn't create any pods. I hope that helps. Raku asking, if the scheduler itself doesn't exist, the pods are getting scheduled because we have only one node. No, nothing will ever be scheduled if the scheduler doesn't exist. You will have to fix your scheduler or set the node name on the pod spec for everything that you need to be scheduled. A1N3IS, thanks for this. You're welcome. I'm having a whole bunch of fun doing this. Raghu, okay, you were wondering because the first pod spec had a node. Yes, that's intentional in the automation. So my automation wants Postgres and Clustered to be scheduled and then breaks it. So those things are already have the node name applied by the scheduler, then the scheduler is removed. So nothing new will be scheduled. And that's true for all Kubernetes components, right? This is an eventually consistent system. So it's okay when things break because the workloads in your clusters will typically just work and they'll churn along as if nothing has happened. But no new changes may work that well. Michelle saying, thank you, understood. My pleasure. Kumar K, can you explain to me the kubelet identity? Can you elaborate on that question, please? Ashcan, how to identify static pods via the kube control command? Oops. All right, let's try something fun at the start of cluster 3. Yeah, let's take a look at that. We'll need to wait. I need kube control. What the more interesting question here is what happens if you delete a static pod? Sorry, static manifests create mirror pods. But yeah, I often say static pods, but I guess technically, to be correct, it is a mirror pod in the Kubernetes source code. All right, we got it. So let's hit start. Pop is closed, and this is the kube admin cluster. But we have to export a kube config. Kumar, yes, I will cover finalizers before we finish. In fact, let's just do it. I can't remember what's wrong with this cluster. I don't remember what's wrong with any of these clusters. I broke all 6 with a whole bunch of different variety of fixes, but I actually don't remember which is on which. Okay, we have no API server. Okay, so that means I'll tackle the finalizer question just now. What is the finalizer? So let's assume you have a Kubernetes an application running on Kubernetes that speaks to an external API. What if your application creates S3 buckets for developers? Excuse me. What if your application creates S3 buckets? Now, if you destroy the application or delete the application, you could be left with a whole bunch of S3 buckets that you're paying for, depending on how much data is in them, of course. And you may not want that to happen. You may have constraints that say, actually, when I delete my application from my cluster, I want it to clean up after itself. I want something to clean up after itself. I want it to delete all those S3 buckets. So you can actually apply a finalizer that says when this resource is deleted, only accept the delete or only complete the delete when the finalizer says it's safe to do so. So what this means is you can say add a finalizer to my application, which calls this other controller, which is my cleanup controller. And when the cleanup controller says it's safe to delete me, I will delete. That cleanup controller will then delete all the S3 buckets and then return a success, allowing your application to be deleted. So a finalizer is a way to ensure that arbitrary code is executed or arbitrary commands are executed before a resource is ever truly deleted from the cluster. Finalizers are wonderful things that allow you to build in lifecycle hooks that just weren't possible before. However, when you're trying to delete something and there's a finalizer that's failing to complete, it's super frustrating. So, Kumar saying cleanup controller manages the finalizer. Am I right? Yeah, so finalizers do cleanup tasks and they handle any administration work that you need to run before the workload disappears. Cool. Let's work out what's wrong with this cluster. So, kube control get pods -a is currently failing to get anything. I'm going to let this time out to see if we have any error message to give us an indication of why this command is failing. Okay, Sandeep saying, yeah, I had faced this. Deleted application, but there are lots of custom resources left on the cluster. Yeah, good use case for a finalizer. All right, Kubernetes, what's going on? Avalanche tells me the API server is not responding. Definitely looks that way. But the interesting thing is the way in which it's not responding. We're getting a timeout, or potentially is going to time out sometime soon. There we go. Yeah, so timeout, the server was unable to return a response in the time allotted. So when we see something like this, we need to be able to understand the state of our control plane, even though we can't query the control plane. Now, a cool tip here is to add, change the verbosity level. So you can do kubecontrol -v equals 9. 9 is the highest level. And then run get pods, and we'll start to see everything that's happening here. We can see that it is speaking to what we hope is the right cluster. You know, we can see the endpoint is a 10.5. This is a local IPv4 address. It's actually trying to get to the pods. It looks like we're able to actually open the connection, but we're not getting a response. So you can see here that open has succeeded, but we're not getting enough information back. All right. Vishal asking, how can we define finalizers to make sure it does the cleanup? We don't really have enough time to cover that and still get to a cluster fee. So either DM me on Twitter or I can give you some links to the documentation. Happy to talk about it, but just not right at this time. Although I will point out that there is a finalizer, a non-destructive and non-breaking finalizer in one of the clustered sessions, not this one, but it is in the last 3. Okay, so we're going to check for our API server components. So we can run PSEUX grep. There's no API server. We can run etcd. Now we have an API server, but no etcd. Right? Interesting how the timing worked there. If I run APIs again, okay. That's a good indication here. We didn't have an API server. We had an API server, and I'm sure if I run it again, it'll probably disappear again. So we have a flapping API server. API server that's going up and down. Do we have a scheduler? We do. Do we have a controller manager? We do. Do we have well, we do have a kubelet because we have the meta pods, right? So this is a delicate situation with Kubernetes because we can see we have an API server some of the time, but we're not able to query it. And we can see that the connect succeeded. But this is where we have to fall back on our traditional Linux knowledge. Well, how do we debug broken applications on a Linux machine? We jump to the logs. So with kubeadmin-based clusters, there are 2 places you can go to get your logs from containers. You can go to var log containers, and we could grep for API, and we'll see our API server logs are here. There's also var log pods, which will give you a slightly different way to visualize and navigate the exact same resources. This is just pod-based. The other one is container-based. I typically prefer the container-based approach. You can do a tail on this log. And we can see here, we have no connection to etcd. This is our first etcd bug. Shit. So let's run grep etcd again. Etcd is not running. So we have to try and work out what is going on. So the next thing we need to know is, well, do we have any etcd logs? And we do. So we know at some point etcd was running. We can copy that, and we can start to dig into this. In fact, why don't we open this one and see if it gives us a bit more information? And we can see, are there any errors? Ha! Cannot assign requested address. So our etcd is unable to start. So I'm going to go through this one without giving you the 30 seconds, just to leave a little bit of time at the end so we can have a chat. But I'm going to go straight to the manifest directory because we have an error message that says etcd cannot bind to the requested address. So what address is it trying to bind to? Well, most important addresses in here, and you'll see it on repeat, is our advertised client URL and our listen peer. So we're seeing this 10.5.1.2.15 over and over and over again. That's in here a whole bunch of times. The first question is, well, what is the IP address? How do I understand the IP addresses on this machine? Well, we can run IP addr show. And we'll see here that the local IPv4 address for this machine is 10.5, starts good, .1.17. So this is different. So our error message is telling us that we're trying to bind to an IP address that actually isn't attached to any of the interfaces on our machine. So we could add the IP address knowledge. We can add that IP address. Sorry, I was reading the comment. Yeah, Avinash, I know not a lot of people are going to have this Linux knowledge, but don't worry about it. I'm going to walk through it. So we could add the IP address if we own it, right? If it's part of our infrastructure to this machine. However, we can just use the private IPv4 address that we know works. So I'm going to come into here, and this is the command to do a search and replace and bin. I'm going to do 10.5.1.215, swapping it for 10.5.1.17. Copy this. I think that'll work. Maybe I should have ran it first. I never remember if you have to skip the dots in the start. So let me change that. .5.1.215, 10.5.1.17. There we go. Command. So concepts is how we got the 215 in the first place. It's just a typo. It's just a misconfiguration. Whoever set up this machine used the wrong IP address for etcd. Very easy done, especially when you're copying configs from machine to machine. So we're going to save that with the correct IP address. We're going to do a PSAUX. I don't see etcd just yet. I could give it a few seconds, and then if I'm impatient, I can restart the kubelet. Remember, when you modify a static manifest, it can take up to 4 minutes. Yes, Russell, whoever. It can take up to 4 minutes before we see that pod being recreated. Now, if we run PS, we actually see etcd is now running, and our API server looks okay. Well, it hasn't flapped in 60 seconds, which is better than it was doing. Why don't we come back to our get pods? And it worked. Now, I still had the V-9, -V9 there, so we had a lot of information. But now we have a working API server. So we can see Cilium, Core DNS, etcd, etc. Things look a little bit better. Okay. Now, there was a question earlier, what happens? Or how can you tell if something is a mirror pod? To be honest, I don't think you can. So we're going to describe our scheduler. And if we pop to the top, we'll see we have kube scheduler, it has a namespace, it has a class name, which we would expect. Nice. There's an annotation. So there we go. We have config hash, config mirror, config seed, and config source. So the kubelet is actually injecting these annotations. I'm assuming that's a hash of the file as it stands right now, and a hash of the applied configuration to the mirror pod. Those are the same, so the kubelet knows it doesn't have to make any changes, and the time that the change was seen, and the source of the file. So we actually do have a way to tell if it's a mirror pod, which is cool. Let's try and delete it. I don't think you can. I think it just pretends to delete. Well, we have another bug in this cluster. We'll try that again, maybe when we fix it. Avinash is saying, I have to spend more time learning Linux. I can tell you my experience, and if anyone else in the chat wants to share theirs, learning Linux and the knowledge that you get from learning Linux and applying it daily or as much as possible to your development or operations or data science career pays back dividends compoundly. Like, I think Linux knowledge is one of the most important things I've ever learned in my career, and they're applicable to pretty much everything else that I do day to day. So I think it's not time wasted. I think learning enough Linux to be dangerous and improving that whenever you can is a very, very valuable use of your time. Okay, concept's the same, but of course services are not running. Wouldn't the cluster be not ready? Cool. Okay. Back to that. Okay. So, of course services are not running when the cluster be not ready. No. Nodes are always ready as long as there is a working CNI within the cluster. There's networking between the nodes, and the kubelet is reporting. That is all that it means to be ready in a Kubernetes concept. You don't actually need anything else. Plus, if you lose your API server, the kubelet can't even update or report back that your node isn't ready. So you end up in this weird situation where you're not able to get enough information across to even update the API server. Russell adding, don't matter pods have the node name appended to them? All daemon set nodes have that too. So you wouldn't be able to distinguish between a daemon set and a mirror pod without noticing those annotations, which I only just learned today about the annotations. So yeah, I didn't think there was a way to tell, but it's cool. All right, let's go back to our error message. I tried to delete a pod and we got another error message from etcd. And it's telling us that, hey, we can't write to etcd. We've run out of database space. Oh dear, we have another etcd problem. So let me be very, very honest. etcd sucks. Not because it actually sucks. It sucks because I don't know enough about it to operate it well. I always on Klustered use the same etcd cheat sheet. And I always go to Google, search for etcd cheat sheet, and it's the DevOps Buzz one. Why am I sharing this? Because at some point, you're going to need it. These 4 lines, unless you've got an eidetic memory, you're just never going to remember them. Let me paste the URL into the chat. Bookmark it, or just learn how to Google it with the same terms. But these 4 lines are how you allow your machine to speak to etcd. Next, we have to install etcd client, like so. What does this allow us to do? Well, we can now run etcd control, endpoint status, endpoint health. We can see that our etcd cluster appears to be okay. Now, we know that we're getting an error message from the API server telling us that the database is full. How can we tell that from etcd control? Well, etcd control comes with alarms. If we run alarm list, we can see that this member on our cluster, right? This is this one node etcd cluster, so it's just one, has a no space alarm. That means that, yeah, we can't write to it. Now, as part of our debugging process, we may run df and scan through this to see, do we actually have a full disk? Oh, like, what's going on? How do I get more space? And you can ignore lookbacks; they're always 100%. But we can actually see that we have plenty of space on this disk. And again, we're getting very, very close to the end, so I'm going to go a little bit faster here. But please feel free to reach out to me and enjoy the other 3 clusters, and I'll help you as I can. But we're going to look at our configuration for this. And if you scroll down this file, you'll notice that the last parameter when we configure this etcd cluster is to add a backend quota. What we're saying here is that we never allow this etcd instance to write more than, I think, what is 3 million bytes to megabytes. I don't know, 8 meg, something like that, or 25 meg. So we can just remove that limit. We can remove the quota, we can make it bigger, whatever you want. I'm going to remove it for right now because I can't remember the correct size that we need to set that to, and save this. Kubelet will detect this change. In fact, I wonder if we can be fast enough, well, not now with this typing, but to describe and see that change. Oh, well, we can't because there's no etcd. All right, we're waiting for SCD to restart. So we've removed the quota. This will allow writes to work, hopefully. But there's actually one more hoop you have to jump with etcd, which is why this example exists. I'm going to show you that in just a second. Where's my PS? There we go. Now we have an SCD without the quota. So we can do kube control get pods, and we were going to delete a mirror pod. We still get the database series. So this is intentional to highlight something that frustrates the hell out of me with etcd. Alarms don't auto clear. We run alarm list, it's still there. So etcd is not checking to see if that alarm can be removed. You have to do that manually. The easiest way to do that is to disarm, like so. Now when we run alarm list, it's gone, and we can run a delete on that mirror pod, and now we can finally see what happens. Hey, it does get deleted. So the kubelet does reschedule it. So there we go. Let's check if we can get our clustered application running. Not quite yet. So let's check for deployments. And obviously we've got something else that we need to fix here. So Kumar asked, what's the default quota for etcd if we remove that line? So I'm not sure, but 250 meg does stand out as some arbitrary value, but I don't remember why. But we can Google it, right? You don't always have to know the answers. Default backend quota. 2 gig. There we go. I'm very trusting of that first hit on Google, but that's fine. Okay. Almost there. So let's describe deployment clustered. And we can say that it's set replica to 1. Let's get RS. Okay. Let's describe replica set. Okay. Now we have a new error message. So our replica set controller can't create any pods because we have a default, something called a default quota, which is telling us that we can't allocate any more memory or CPU for this cluster. So we can actually run the API resources grep for quota, and we'll see resource quotas there. There are more ways to set quota-based style quality of service-based improvements within a cluster. There's also limit ranges, and there's also custom controllers. So there's loads of ways to do it. But today we use the resource quota. Here I could delete our resource quota called default quota. And you can see this was actually just blocking pretty much everything. Nothing would be scheduled in this namespace. Now we can write pods. We could probably stick that on a watch, and at some point, I mean, we could speed that up and delete some replica sets. Depends how quickly I think I need to go. I don't know if Siam has anything after this, and I don't want to assume. So I'm going to delete all replica sets. I'll let the deployment controller pick that up. In fact, you'll probably find it's already created a new one, and we've already got our pod spinning up, so our applications should become healthy in just a moment. It's running. We'll go to the web app. And we have the watch tab. Now we can come back, edit our deployment, clustered, and set our image v2. If we watch that, I didn't think there was another break. Hold on, describe pod. I actually have run out of memory now. That was unintentional. I'm going to delete our old pod. See if that encourages it. Cool. So our v2 is now in container creating. This is going to be a little bit confusion, but we will see the dance, and our old replica set pod is trying to be recreated. But we could just delete that replica set and get that to go away. And if we pop open to our web app, you should see the dents. All right, that last cluster was really fast, just the time, but I hope that it shows you etcd alarms. They need manually disarmed. You can configure the backend quota, and resource quotas are a good best practice in Kubernetes. So make sure you understand the resource allocation requests and limits of your pods and how that affects scheduling across the broader namespace. All right. Sam is popping back in, and I'll check for any more questions.
Awesome. So I think that was amazing cluster breaks. Again, thanks to Rockwood for bringing such hands-on labs interactive so that you can actually do it. And I saw like there are still so many people watching it and doing just to make you dance, which is amazing. Which is amazing. So I think that's amazing. So thank you everyone who spent their 2 hours learning Kubernetes troubleshooting tips and tricks. I hope you learned something new. I'm pretty sure you learned something new today from the 3 broken clusters. And yeah, that was fun. And thanks to Instruct and Rockcode for bringing these hands-on labs, because previously we were thinking of having a mini cube, but again it would have taken more time in the setup and stuff, and this is much more much more well structured, and you have a terminal, everything is working. So that's pretty neat. So thanks again, David, for giving us your 2 hours and all the knowledge that you have gained from the Clustered series and these amazing labs. And thank you so much to the audience who stayed till the end. That is very important. You learned so much, and everything was went well. So thank you, David, and thank you all for tuning in. And make sure to, yeah, all the usual stuff, like the video, share the video, subscribe to the channel, press the bell icon, and everything. And do that same for Raw Code as well. So you have to subscribe to Raw Code channel, press the bell icon over there as well, and follow both of us on Twitter. And make sure to follow Kubesimplify. And thanks to all the ambassadors for setting most of the things up. And the next workshop will be Kubernetes observability, I think, which is happening on 19th of September, which will again be very interesting in the observability ecosystem. So make sure to attend that as well. Yeah, David, any last words for the audience?
No, thank you for following along. Definitely check out the last 3 clusters. See if you can complete them. They are a little bit tricky, but I'm confident you can do it. I'll keep an eye out in the Kubesimplify Discord. You can ask questions there. I'm also available via Twitter DM. So if you do need some help or advice, feel free to reach out. And best of luck. But thank you very much for having me, Sam.
Amazing. Thank you all. Bye. See you in the next one.